Alright guys, welcome to lesson 3.8. We're looking at something called the IVT today, which is the intermediate value theorem. Come to think of it, I've incorrectly labeled this. It really should just be titled IVT, but it's really just the second part of the 3.8 notes that we haven't finished yet, so that's why I labeled it that way. But it's okay, you don't have to change the label of your notes. But we're just focusing on one concept today. It's called the IVT, or short for Intermediate Value Theorem. Let's go ahead and ponder a quick question here. So pause the video here and think about your answer to this question. All right. Well, there's a few different ways I could think of to solve this, but I think the easiest way to explain it on the whiteboard here would just be by graphing it. So I mean, if I were to graph the point 0, -1, that would be like right there. And if I were to graph the next point 4, 3, that would be right there. And then if I were to graph the point 7, 5, be here, and then finally 10, 0. Now the instructions up here say something very important that we can't ignore about this function. It says it's continuous. All right, and so what that means is that starting here, I should be able to connect these dots together by one line without any holes, gaps, or jumps. Now the question here is, what is the least number of times that f of x could possibly end up equaling x, or possibly be equal to 2? Well, f of x is a y value. Well, I could see two places where the y value is 2, like maybe like right about here, and also like maybe right about here. All of those are at that height of y equals 2. So I would say a good answer to this is 2 times. But you notice that I said what's the least number of times? And that's because I could connect these dots in a slightly different way that will give me more answers. Let me show you. Back up a little bit. Almost there. All right. So I can connect these dots in another way. I can do this, can't I? I mean, it's still a continuous line. It still hits all the dots. It's just a really weird way to do it. But technically, I could do that. But by doing that, I end up with a lot more spots that are equal to 2 in their height, or their y value, I should say. So there's at least 2. And that's based on the way that I drew it at first. I mean, you're not going to be able to connect those dots in any way that's going to give you any less than what I had there. It's impossible. Okay? And the reason for that is because if I have to cross this this little boundary line right here, which is where y equals 2, well, in order for me to get from this point to this point, if it's a continuous line, I have to cross that line at least once, right? Now up here, I could do whatever I want. It doesn't really matter, but in order to get from this dot to this dot, I've got to cross it again. Okay, so it has to at least cross twice that y value 2. You can see that on the table also, by the way. If we're going from -1 to 3, well, somewhere along the way, it has to cross 2, right? Now, if I'm going from 3 to 5, I don't have to cross 2 to get there, right? I could go to 4 to 4.5 and whatever to get to 5. But if I'm going to go from 5 to 0, then I'm going to have to cross 2 again. So there has to be at least 2 different times where that y value comes out to equal 2. So you could tell it by looking at a graph, but you can actually also tell by looking at the table. There's a homework question like this, so you might want to remember this little strategy I shared with you. But what we just did was we just did what's called the intermediate value theorem. The intermediate value theorem basically says that if you're going from point A to point B, and the question is, are you going to cross some point, which we'll say is some y value? If you're going from point A to point B, well, if that line's continuous, then yes, it would have to cross that line at some point. Okay? And so basically what the intermediate value theorem does is it doesn't tell you what or where it happens at, and it doesn't even really tell you how many times it does happen. But what it does tell you is that it has to happen at least once. Okay, but you notice there's a couple of criteria. First of all, the line has to be continuous. Why does it have to be continuous? Well, just kind of imagine this for a second. Imagine that I had these two dots and I was asking, okay, I want to go from point A to point B. The question is, do I have to cross that line? Well, if I do this and then just decide, oh, I'm going to jump up here now. Well, that's not a continuous line, right? And because it's not a continuous line, no, I actually didn't end up touching that dotted line at all now. So it only works if the line's continuous. Okay, so that's one requirement. Now here's another requirement that we kind of talked about also in our little example that we did. Let's say that I want to go from point A to point B, and let's say I put the y value up here. Well, in order for me to get from point A to point B, even if my line is continuous, do I have to cross the dotted line to get to B? No. So that y value has to end up being between the y values of the 2 points that you have. If it's not in between them, then it doesn't necessarily have to cross that line, right? But it could cross that line, though, don't you think? I mean, I could connect the dots like this, in which case it would cross that dotted line. That is possible. But the question is not, can it? The question is, does it cross that line at least once? And the answer is no, it doesn't necessarily have to cross that line at least once. It does not have to. And so it has to, so the y value that we're looking for has to be between the two y values of the points that they give us. Okay? And so that's basically it. Now you might think, well, what's the point of this? Like, why does that matter? Well, let me give you a great example. Let's say that I tell you I have this function here. And unfortunately, because, you know, you can't solve this very nice. If I said, can you find a place where y equals 0? Or does this function ever have a place where y equals 0? Well, what you could do is you could just plug some numbers in for x and you could find out, well, it seems like y equals a negative number for some values of x. And then you could plug in some more and say, oh, well, look, the y also equals some positive numbers for other values of x. And this is a polynomial, so it's continuous. So if my y value is going from a negative to a positive, then I know somewhere along the way it has to equal 0. And as you guys know, a lot of times in mathematics, we look for the roots, the places where a graph will touch the x-axis. That's when y equals 0. And so the intermediate value theorem can basically tell you if a graph has roots or not. And that's important because sometimes you can't solve it using traditional ways. Like there's no nice way to solve this equation. You'd have to use some kind of technology. So what the intermediate value theorem does for us, at least, is it tells us, well, we know that there's some kind of a root at least worth looking for because it goes from negative to positive, so it has to equal 0 somewhere. So that's the intermediate value theorem. All right. So let's chat about it a little bit more formally now. This is how the intermediate value theorem is actually more formally defined. All right, now mathematicians tend to define things very precisely. So we're going to take this idea, which I tried to make sound a little bit more simple on the last page, and we're going to really define it very precisely now. And it might be a little more challenging to follow, but see if you can kind of grasp the basic idea here. So here's the intermediate value theorem. If a function is continuous on the closed interval from a to b, so in other words, no holes, gaps, or jumps between these two x values, a and b. If that's the case, and the y values for each of those points, f of a and f of b, those y values cannot be equal to each other. One has to be low and one has to be high. So it's continuous and you have two different y values. And suppose you pick some other y value, which we'll call k, which is between those other two y values, then there has to be at least one value c. Now those are x values on the x-axis. There has to be at least one, but there could be more than one. There has to be at least one value c on the x-axis that's between the other two x values, a and b, such that when you plug those values for c into your function, they equal that y value that we're looking at. Okay, and so that's the intermediate value theorem. So I'll go through it a little bit. I'll go through it one more time with you, just to kind of drill it in. If you have a function that's continuous on an interval from a to b, and f of a is not equal to f of b, and you pick some k value between f of a and f of b, then there has to be at least one c value between a and b, such that f of c is equal to k. Okay? And that's the idea there. There has to be at least one. And so the intermediate value theorem just guarantees you that there is some y value in between the two y values that you have. And there has to be some c, some x value that gives you that y value. Okay? So a lot of the battle with these particular problems is recognizing when they want you to do it, and b, wording it correctly, because the way that you word it is very important. And so I'm actually just going to give you guys a little template of what to say. Matter of fact, I'll bring it up here real quick. It looks like this. And if I were you, I would just put that on one of your flashcards. As a matter of fact, I think I printed flashcards for you guys, right? I don't remember if I put this on one of the flashcards. So if I didn't, I would put this on a flashcard and just add it to your repertoire of things to review once in a while. So let's go ahead and apply this problem here. So use the IVT, the intermediate value theorem, to explain why there has to be at least one value c such that f of c equals 5. Okay, now I want to say that in English a little bit. Use the intermediate value theorem to explain why there has to be some x value, which I'm going to call c, such that when you plug that x value into the function, you get 5. Okay, now there's another way we could solve it on this problem. It's pretty easy, but we want to do it using the intermediate value theorem here. Okay, now what's this 0 to 3 here? This is the interval that we're looking at. We're going from x equals 0 to x equals 3. All right, now these steps over here, a, b, c, d, and e, these aren't like problems that I necessarily want you to do, although that's how we're going to treat it. But what these are is these are kind of like steps we need to follow, but the final answer is going to be filling in these blanks in this statement over here. Okay, so a through e is really just a way, a through d I should say, is really just a way to kind of prepare yourself to give the final answer. All right, so let's begin here. Identify the a, the b, and the k. Okay, so what do I mean by that? Well, the a and the b are the x values of your interval. So my x values are going from 0 to 3. Okay, and my k value is the y value that I'm trying to equal. Okay, so I just arbitrarily picked those letters, but those are the letters that match the graph that I gave you on the previous slide. So a and b represent the interval, and k represents that y value that's between my other two y values that I need to find. So there's that. All right, so check. We're good. The next thing we need to do is we need to see if it's continuous or not. And the answer is for this, is this function continuous? And the answer is yes, because it's a polynomial. Once again, you have that little sheet you want to look at that I gave you back in lesson 3.3, part 2, which is called the continuity of common functions. And polynomials, as we said before, they're always continuous, so they don't have any holes, gaps, or jumps. Now that's important because if you want to do the intermediate value theorem, you got to remember it has to be continuous. Okay? So sometimes they'll give you questions on the AP exam where they'll say, can you use the IVT here? And you would have to say, well, is it continuous? That would be one of the things you'd have to look at. And we'll do some problems like that, actually. All right, now the next thing is we want to find f of a and f of b. So that means we're going to take these x values of 0 and 3, and we're going to plug them into our function to find out what are the y values that go with each of those. So let's do that. F of a and f of b. So f of a will be 4 times 0 minus 3, which is negative 3. So I've got that. F of 0 equals negative 3. Next one. That's going to give me 12 minus 3, which is 9. So let me write that down real quick. Okay, so my y values now, as my x values is going from 0 to 3, my y values are going from -3 to 9. So now, part D, verify that k is between those two values. In other words, my k value is 5. Is 5 in between these two numbers? Yes, it is. So I'm just going to put check. 5 is between -3 and 9. All right? So before I actually get into the rest of the final solution, I just want to draw you a picture. Okay? So we have, right now, we've just found that there's 2 points. We have 0. When I plugged in 0, I got -3. So 0, 3. And when I plugged in 3 for the x value, I got 9. Now the k value I'm looking at is 5. If I want to connect this point to this point and my function's continuous, do I have to cross it at least once? The answer is yes, I do. And therefore, we know for a fact there has to be some x value down here, which I'm going to call c, on the x-axis, such that when I plug in c to my function, I get a y value that's equal to k, or in this case, 5. Okay? So all this stuff we just did was to set it up. So identify a, b, and k. Check to see if it's continuous. It was a polynomial, it was. We found out that f of 0 was -3 and f of 3 was 9. And that meant that our k value of 5 was between -3 and 9. And so now we're ready to actually go ahead and write our statement out and have our final answer. And here's how you would word it. Since the function is continuous and it goes from -3 to 9 on the interval from 0 to 3, there must be some value of c on that interval such that f of c equals 5. And there it is. So you put your two y values here. You have to specify the interval that you're working on. And that means there has to be some c on that interval such that when you plug it in, you do get that y value, because that y value is between your two other y values. So that, in other words, on that interval, the function has to cross the y value of 5 to get there. But that's how you would word it. And I would just say, like I said, commit this little paragraph or sentence here to memory, put it on a flashcard. And all you have to remember is you put your first y value here, your second y value here, you put your interval here, and you put the k value there. And you're going to get it right. Now you still have to make sure it's continuous. You still got to make sure the k is between the a and the b. You still got to find those other y values. But this is how your final answer will need to be expressed. Now the only problem with this is that memorizing things is great, it's helpful, but you got to understand what I'm talking about too. So don't forget about what the IVT actually means. So let's keep it simple there. It just means that if you go from one y value to another, at some point it has to cross some y values in between that, right? That's basically the idea. All right, so let's go ahead and do a guided practice here. So that means I'm going to ask you guys to pause the video after every step and see if you guys can accurately do each one. So here we go. Part A. Pause the video and see if you can identify A, B, and K. All right, so hopefully you recognize that A is 0, B is 1, and this one's a little bit tricky, but look at it. Use the IVT to explain why the function has a 0. That means we're looking for a place where the y value equals 0, and so my k value in this case is 0. So sometimes they will word the question that way, so don't be surprised when you see that. All right. Let's go ahead and take a look at part B. Check to see if this function is continuous on the interval. Now, before you guys start, this is a rational function. And rational functions do have discontinuities. But we just want to make sure that it's continuous on this interval. So go ahead and pause the video here and see if you can find the discontinuity. And then see if that discontinuity is on the interval we care about or not. All right, well, what we've learned is we've learned that with rational functions, anything that makes the denominator equal 0 is a discontinuity. So this function has a discontinuity at x equals -1. But that's okay for this particular problem, because since -1 is not on our interval, it's okay. To use the IVT. So -1 is not on the interval from 0 to 1, right? That's outside of the interval. So I can do the IVT on this interval. That's okay. Even though this function has a discontinuity, the discontinuity is not on the interval that we actually care about right now, so it's okay. It wouldn't be okay if I said, can I do the IVT on this interval? If I gave you guys that, you would say, no, I can't do the IVT there because there's a hole, a gap, or a jump, which means my function may not cross the y value that we think it should, okay? But in this case, the answer is yes. Once again, it is continuous on the interval. All right, next step. Go ahead and pause the video here and see if you guys can find f of a and f of b. All right, so here's what I get. F of a, which basically means f of 0, is -3, because if you plug 0 into this function up here, you would end up with -3 over 1, which is -3. And then f of b, which is f of 1, means I plug 1 into that function, and by plugging in 1, I end up with 3 over 2, which is 1.5. Now, next question. Verify, make sure, see if it's true. Is it true that k is between f of a and f of b? So, you guys see, is our k value between f of a and f of b? Pause the video here and see if you can figure that out. When you're undone, unpause it and you'll see. So our k value is 0. My f of a's number is -3. My f of b number is 1.5. Is 0 between the two y values? It is. So that means we're good to go. That means there has to be somewhere on the interval where there's an x value, where if I plug that in, I'm going to get a y value of 0. Okay? So let's go ahead and clear all this stuff off, and I'm going to have you guys fill in this statement now. Pause the video and see if you guys can accurately fill in that statement. All right, so here's what we should have put. Since the function's continuous and it goes from -3 to 1.5 on the interval 0 to 1, there must be some value c on that interval such that f of c equals 0. Okay? It's very wordy, very wordy. But once again, put it on a flashcard, memorize it, and understand it. Understand what it means, okay? And this is not the only way to word it, but all this stuff, the crucial stuff that you need to say is that the function's continuous. Somehow you need to make the statement that your function's going from one y value to another, and that would imply that the k value that we want is between those two numbers, and then you have to include your interval. So you have to include those kinds of things in there. But that's not the only way to word it. That's just kind of the easiest way I could find to word it, but there you have it. But you got to understand, if they have a multiple choice test, and I don't know if they would do this. I have seen a question actually where they do it, so it's not very often, where they actually write out sentences and you have to pick out which sentence it describes the situation at hand. They might word it a little different. So it's important to understand not just this thing and how to write it yourself, which is very helpful for FRQs, but for other situations, you actually understand what it's saying so that if somebody words it a little bit different, you still get the same basic idea. All right, so now you guys are ready for a student practice. So that means I want you guys to verify steps A through D like we have been, and then I want you guys to actually write out the sentence on your own there, okay? And I would encourage you, before you start, to try to write that sentence out without looking at the ones we've written before. Now, if you need to look, that's fine. But this is a place where instead of just trying to copy what I wrote, try to actually articulate it in your own language so that it makes sense to you, okay? But either way, at the end, you got to make sure certain parts are there, and we'll go over it. But anyway, pause the video here, and when you unpause it, I'll have the solution up. Okay, now, here's the final answer, and a lot of you guys might have gotten there, but there might be some subtle details that you might have missed as you got there, and even though you got the right answer in the end, there's some things you want to pay close attention to here on this problem. Okay, so I'll just start from the beginning. A equals 5, B equals 20, and K equals 3. Now, the continuity of this function is one of those details that you might have missed an important detail for. Radical functions with an even root are continuous for everywhere where the part under the root is greater than or equal to 0. So it's only continuous if x is greater than or equal to 0. So is that on the interval? And the answer is yes. Okay? Since we're looking for values of x that are greater than or equal to 4, anything between 5 and 20 is going to be greater than or equal to 4. So we're okay there. All right? Here's your two g of a and g of b outcomes, or the two y values that we need. And then finally, our k value is between those two y values, and here's your final answer. Okay? So, that being said, that's the IVT. So make sure that you guys can say it in your own words, like what is it? Try to describe it. Practice. I might have even put a question like that in your homework where you just try to describe to somebody what the IVT is. But in your final answer, you need to state a couple of things. You need to state that it's continuous, that the function goes from 1 to 4 on the interval, and then you have to actually say, yes, there either is or there isn't some kind of k value. So these 5 things need to be present in your answer in some way, shape, or form, and they have to connect in a way that carries the same sense. All right? All right. That being said, now we're going to move on to a new question. We're going to come across situations where you're not allowed to use the intermediate value theorem. All right? And there are 3 things that could cause you to not be able to use the IVT. So I'm going to back up a little bit here, and we're going to go back to our intermediate value theorem. If any of these 3 things don't happen, then you can't use the IVT. You can't be sure that that y value actually exists on the interval that we care about. So one thing that could cause us to be unable to use the intermediate value theorem is that the function's not continuous. Another thing is if the two y values are equal to each other, then we can't do it. You can't have f of a and f of b having the same value. It's just not allowed. Otherwise, you can't use the IVT. And then finally, you need the k value that you're looking for has to actually be between those two y values that they give you. So 3 things have to occur if you want to be able to use the intermediate value theorem. And if one of those 3 things fails, then you can't use the IVT. And I've got exactly 3 problems here. And on all 3 of these, I basically picked 3 problems because each one of these is going to fail in one of those ways. Okay? So, first of all, let's go ahead and start by finding, is it continuous on the interval? I shouldn't say it. I should say, is f of x, the function, continuous on the interval that we're looking at? So, is this function continuous on this interval? Well, as you guys know, this is a rational expression. And rational expressions have discontinuities for whatever makes the bottom equal 0. So in this case, x cannot equal 0, right? Because if x equals 0, then that means we have a discontinuity. Well, is 0 on this interval? Is 0 between -1 and 1? It is. And so the reason why you can't apply the IVT here is because the function f of x has a discontinuity at x equals 0, which is on our interval. So you can't use the intermediate value theorem because we have a discontinuity on the interval that we care about. So we can't be too sure that any y value would specifically exist because the one y value I'm trying to find, what if that one y value would be right where that hole was at? So we can't be sure that any specific y value exists on that interval because of that. All right, let's go ahead and take a look at the next one here. So we're going to start off with the same question. So question 1, is the function continuous on the interval? Now for this one, the answer is yes. Because this is a polynomial. Polynomials are always continuous. So there's no discontinuities. So far we're good. Now the next thing we need to do is we need to look for what is f of a, and we need to look for what is f of b. Okay? So let's do that. So we have f of -1 is going to be -1 squared minus 1, and f of 1 is going to be 1 squared minus 1. Now 1 squared is 1, and 1 minus 1 is 0. 1 squared is 1, minus 1 is 0. They're equal. And that's a problem for the IVT. Your two y values cannot be the same outcome. They have to be different. So for this one, we're going to say can't use IVT. Since f of 1, or -1, is equal to f of 1. They have to be different. They can't be the same. So if you're not going from one y value to a whole different y value, then it's not going to cross anything, right? Technically. Maybe it does, but there's no way for us to know. If our two endpoints have the same spot, the same height, the same y value, then we can't be sure it's crossing anything at all. It might just stay at that y value the whole time. So we can't use the IVT if the two y values are identical. Okay, so that's why that one fails. So the first one failed because it wasn't continuous on the interval. The second one failed because the two y values were equal, and you can't have that. All right, let's go ahead and take a look at the last one here now. Is it continuous on the interval? Yep. Yes, it is, because it's a polynomial once again. All right, how about f of -1 and f of 1? Let's see what happens with those this time, because we've got to make sure those two y values come out different. So if I have that, I'm going to do -1 squared plus a -1 plus 1. And then for f of 1, we're going to have 1 squared plus 1 plus 1. Now this one here comes out to be 3, and this one here comes out to be 2 minus 1 is 1. So they're not equal, and that's good. We like that. They need to be different y values. Okay? So we've got a continuous function with two different y values, but there's one more thing we have to check. Not only does it have to be continuous, not only do the two y values have to be different, but one more thing. The k value has to be between the f of a and the f of b. Actually, I'm going to mess with these arrows a little bit because sometimes the arrows don't go the same way. So for now, I'm just going to put it like this. Is the k value between f of a and f of b? Well, f of a was 1 and f of b was 3. My k value, I'm looking for where k equals 0, is 0. Is 0 between 1 and 3? No. So on this one, we're going to say we can't use the IVT since 0 is not in between f of -1 and f of 1. Okay, so that's the third thing we have to check. The function has to be continuous on the interval that we care about. The two y values have to be different. They cannot be the same. And even after that, we got to make sure of one more thing. We have to make sure that the k is actually between those two y values. And in this case, it's not. So those are three different things that would make it impossible for us to use the IVT. Okay? Now, just for the heck of it, I'll give you a graphical explanation just to kind of bring it to life a little bit. So for the first one, let's say that we're going from -1 to 1 on the x-axis. And when I plug in -1, I get -1. And when I plug in +1, I get +1. And the question is, does it cross the x-axis? Well, this function's not continuous on the interval. So, and actually, if you graph this, it looks something like this. So, does the graph ever touch the line where y equals 0? No, it doesn't. And so, since there's a discontinuity at x equals 0, we cannot be sure that it actually touches the y value, which is between these 2 points. We can't be sure it crosses the y equals 0 point. So that's the explanation for 1. Let's take a look at the explanation for 2. The explanation for 2 was that for the x values -1 and 1, they both ended up having the same y value, which is 0. So, does it cross 0 in between those points anywhere? It doesn't. It's kind of hard to tell. What if I graphed it like this? It's not crossing this y equals 0 line anywhere in between them, right? So now I understand it touches at the endpoints, but I'm asking, does it cross anywhere in between? And the answer is, well, we can't be sure. It could, if I were to graph like this, but we can't be sure that it actually does that. And our problem was because these two y values were exactly the same. All right, now let's take a look at the last situation. In the last situation, at -1, we had, what did we have for that? 1 minus 1, 0. I think it was 1, wasn't it? And then at 1, we had 3. And the y value I'm looking for is 0. So if I'm going to connect these two dots here, does it have to cross the x-axis at any time in between there? No, because those 2 points are above the x-axis. In other words, the y value that I was looking for is not between the two y values that we have. So those are the 3 reasons why the IVT can fail. All right, so here's one for you. Now you guys only have one. And your job is to figure out, is this function, well, actually I'm telling you now, you cannot use the IVT on this problem. But the question is why? Now you've got 3 possibilities to explore. So go ahead and pause the video here and see if you can find the reason why we're not allowed to use this function on this interval for the IVT. And pay attention, I've got a different k value for you. Your k value is 1. So here we go. Is it continuous on the interval? And the answer is yes. This function does have a discontinuity at x equals -3, but x equals -3 is not on our interval. So we don't care about that discontinuity, and so we say yes, we're good to go there. Next one. We got to make sure that f of -2 and f of 1 are different, and they are. Plugging in -2, I get -3. Plugging in 1, I get 0. So that's good too. So the reason it must fail is the last one. The last one is the fact that this y value is not between these two y values. And so that's going to be our answer. Since f of c equals 1 is not in between f of -2, which is -3, and f of 1, which is 0, we can't use the IVT. Okay? Now you didn't have to say the f things. You could have left that out if that's confusing to you. it doesn't matter. You don't need that. You could say, but since 1 is not between -3 and 0, we can't use IVT. Okay, but there you guys have it. That is identifying reasons why you can't use the IVT. All right, so we'll leave it at that, and we'll see you guys next time.